Hello and welcome back to another Duncan Codes. My name is Duncan, and today we're continuing with the University of Helsinki's massive open online course, and we're on part 5, Objects and References, and our objectives today are to brush up on using classes and objects, know what a null reference is and what causes the null pointer exception error. We can use an object as an object variable and a method parameter. You can create a method that returns an object, and you can create the method equals, which can be used to check if two objects of the same type have the same content or state. Let's continue working with objects and references. Assume we can use the class that represents a person below. Person has object variables name, age, weight, and height. Additionally, it contains methods to calculate the body mass index, amongst other things. Okay, so looking at this class, we can see we've got some instance variables or encapsulated variables here at the top. We have two constructors. We've got this one here, and we've got this one here as well. And then we've got other methods that we can use and override to the .toString method, so we can see roughly what will print out. And we can see that the constructor either takes a name or a name, age, height, and weight. So we've got quite a bit of information just from looking at that class. So person Joan equals new person Joan Ball. So we're using a constructor that is just using the string name. Calling a constructor with the command new causes several things to happen. First, space is reserved in the computer memory for storing object variables. Then default or initial values are set to the object. For example, an int type variable receives the value of 0. Lastly, the source code in the constructor is executed. A constructor call returns a reference to an object. A reference is information about the location of object data. So the value of the variable is set to be a reference, i.e., knowledge about the location of our related object data. The image above also reveals that strings, the name of our example person, for instance, are objects too. That must be age, height, and weight. Assigning a reference type variable copies the reference. Let's add a person type variable called ball into the program and assign Joan as its initial value. What happens then? So here we've got our person and our object is called Joan, and we're saying that that's equal to a new person, and the string value is Joan Ball. If we print that out, because we've got the .toString method, we should get a nice printout. And here we've got another constructor, person Ball equals Joan. So what we're doing is we've given Joan a value here, and we're assigning that value also to Ball here as well. The statement person Ball equals Joan creates a new person variable Ball and copies the value of the variable Joan as its values. As a result, Ball refers to the same object as Joan. Let's inspect the same example a little more thoroughly. Let's see what their explanation is. So Joan Ball, i.e. the person object that the reference in the Joan variable points at, starts as 0 years old. After this, the value of Joan variable is assigned or copied to the Ball variable. The person object Ball is aged by 2 years, and Joan Ball ages as a consequence. An object's internal state is not copied when a variable's value is assigned. A new object is not being created in the same statement person Ball equals Joan. The value of the variable Ball is assigned to be the copy of Joan's value, i.e. just a reference to an object. So they're both pointing to the same object. So just to recap, up here we've got our object Joan. We're making a reference to Joan here. Ball is growing older twice, and then we're printing out Joan again. We can see that because they're pointing to the same object, that the ball.growOrder has actually had an impact on the Joan reference. An object's internal state is not copied when a variable's value is assigned. A new object is not being created in the statement person Ball equals Joan. The value of the variable Ball is assigned to be a copy, i.e. a reference to that object. Next, the example is continued so that a new object is created for the Joan variable and a reference to it is assigned as the value of the variable. The variable Ball still refers to the objects that we created earlier. So again, we're getting quite familiar with this now. So we've got our object creation. So remember, this is the class name, this is the object name, and this is the constructor. And obviously this is the constructor where we were only passing one thing or argument to it. I think argument would probably be better than thing. We've got person Ball again here. We're printing out Joan. We're saying that here that Joan is actually equal to a new person, and we're giving her the name Joan B, and then we're system out printing Joan. So in the beginning, the variable Joan contains a reference to one object, but in the end, a reference to another object has been copied as its value. Here is a picture of the situation. So what we've got is this code that we're very familiar with now. We're printing out Joan, so we've run exactly the same code as before, but here we're creating a new person and assigning it to that name, Joan. So we're actually updating the data contained within Joan. So you can see how it's following that through. So this is our first printout here, which refers to this line here. Then we are pointing bool to the same reference, or using the same reference as Joan. Because it's the same reference, when we call bool.growolder, we get Joan bool equals 2 years, which is this line here. And then here we're saying that Joan is equal to a new person, Joan B, and then printing out Joan again. And we can see that here, that one is referring to this here as well. Null value of a reference variable. Let's extend the example further by setting the value of the reference variable bool to null, i.e. a reference to nothing. The null reference can be set as the value of any reference type variable. Okay, so let's have a look. So again, this is the code that we've built on from last time. The only difference is that bool is now equal to null. The situation of the program after the last line is depicted below. So here we can see that Joan has a copy or has her link to data here, but bool, he is now null, so he's not pointing to anything. The object whose name is Joan bool is referred to nobody. In other words, the object has become garbage. In the Java programming language, the programmer need not worry about the program's memory use. From time to time, the automatic garbage collector of the Java language cleans up the objects that have become garbage. From time to time, the automatic garbage collector of the Java language cleans up the objects that have become garbage. If the garbage collection did not happen, the garbage objects would reserve a memory location until the end of the program execution. Let's see what happens when we try to print a variable that references nothing. So that's making a reference to null. So here we've got bool equals null, and on this last printout you can see we're printing out the value, and here we get a printout of null. Printing a null reference prints null. How about if we were to try and call a method, say growOlder, on an object that refers to nothing? Again, we've got our code up here, setting the string name. Joan is equal to null. We're calling growOlder on the Joan object, and then we get this null pointer exception. So this is the result, and bad things follow. This could be the first time that you've seen the text null pointer exception. In the course of the program, there occurred an error indicating that we called a method on a variable that refers to nothing. We promise that this is not the last time you will encounter the previous error, but when you do, the first step is to take a look for the variable whose value could be null. Fortunately, the error message is useful. It tells us which row caused the error. So let's see if we can try it ourselves. So we're going to implement a program that causes a null pointer exception. The error should occur directly after starting the program. Don't wait to read input from the user, for instance. Okay, so what we can actually do is just use this code here. But let's get our NetBeans open. Let's see, so this is it, null pointer exception. Let's see what we've got. Implement a program or modify a program so that it causes a null pointer exception. So what we want is for the objects that it's pointing to equal null. Let's just see if we can change this to null and see if we do get a null pointer for this. Let's see what we got. There we go, null pointer exception. We'll have a quick look at this error message, or this exception message, and I'll show you a few bits and pieces. So the error for this is going to be slightly different to an error that you would encounter because we're using a different JDK. We're using the adopt open JDK. If you're using the regular JDK, your error might be slightly different because it won't have these Apache made classes and folder locations necessarily. But what you can see here is that we've got errors on line 764, 711, but actually these are referring to other classes and other objects. The bit that we're interested in is this line here that tells us very specifically that our null pointer exception is on line 21. So we can see that it's here on line 18, but it's made use of, or the line's object is made use of on line 21. And that's where our null pointer exceptions come from. Let's give that a submit and see what we get back. There we go, excellent, let's get that okayed. We have to resize this, there we go. Right, let's head back to here, let's give that a refresh. Very good. Object as a method parameter. We have seen both primitive and reference variables act as a method parameter. Since objects are reference variables, any type of object can be defined to be a method parameter. Let's take a look at a practical demonstration. Amusement park rides only permit people who are taller than a certain height. The limit is not the same for all attractions. Let's create a class representing an amusement park ride. When creating a new object, the constructor receives as parameters the name of the ride and the smallest height that permits entry to the ride. Let's have a look. We have our class here, amusement park ride. We have two encapsulated variables. We've got one constructor here, which is taking two arguments. We've got string name and int lowest height. And then we've got our override to the .to string, which will pretty print, in a sense, our object data. Then let's write a method that can be used to check if a person is allowed to enter the ride, so if they are tall enough. The method returns true if the person given as the parameter is permitted access, otherwise false. Below, it is assumed that person has the method public int getHeight that returns the height of the person. So we've extended, or so the example above has been extended. We have our public boolean allowed to ride, and what you can see here is that we are passing the person data type, or the person class, and the data here as well that we're passing. So the method allowed to ride of an amusement park ride object is given a person object as a parameter. Like earlier, the value of the variable, in this case a reference, is copied for the method to use. The method handles a copied reference and it calls the getHeight method of the person passed as a parameter. Below is an example main program where the amusement park ride method is called twice. First, the supply parameter is a person object Matt, and then a person object Jasper. So you can see that we've got our two object creations here. We've got object Matt, we've got object Jasper, two constructors, and then we are setting the weight and height on these lines here. We now have the water track object created. We have the ride name, and then we have the ride minimum height as well. So remember that the allowed to ride method is a boolean, so it will return either true or false. So we've got if water track, which is the object name, dot allowed to ride, and then we've passed Matt as a variable because remember it's expecting a person. System out print here, Matt may enter the ride. If he doesn't meet that criteria, he may not enter the ride. So we can see here that he should actually be allowed to ride because he's tall enough. And then on this one, we've got if water track dot allowed to ride Jasper, who we can see is 132 centimeters, so he would not be allowed to ride here. You may notice as well that we haven't had to say if water track dot allowed to ride Matt equals true. We don't need to put that in because it will return whether it's true or false anyway, and it will take the returned value as the true or the false. And the output of the program is that Matt may be able to enter the ride, Jasper may not enter the ride, and then it prints out the minimum height and the ride name as well. What if we wanted to know how many people have taken the ride? Let's add an object variable to the amusement park ride. It keeps track of the number of people that were permitted to enter. You can see here that they've gone back and modified the code. We've got that extra variable there. And here we've got an update to our allowed to ride method. So just before true is returned, the variable visitors has 1 added to it. So this could be plus equals 1, plus plus. So remember that the visitors plus plus is the same as visitors plus equals 1, something similar. Now the previously used example program also keeps track of the number of visitors who have experienced the ride. And that implementation is here, isn't it, underneath the allowed to ride method. So every time that the allowed to ride method returns true, 1 is added to the visitors variable, and we can see that here. Development environments can help the programmers. If you created object variables for a class, creating constructors, getters, and setters can be done almost automatically. I'll show you how to do this as well. Go inside the code block of the class, but outside of all the methods, and simultaneously press Control and space. Now, I think that's actually different on NetBeans. I believe it's Alt and Insert on NetBeans. Yeah, it is. Okay, I will show you how to do this. I'll close this down. The shortcut won't be Control and space for NetBeans, for Apache NetBeans, sorry. What I'll do is I'll open this. Maybe I'll get rid of that error. Right, let's see. And in fact, let me cut this. I'm just going to delete it all. In fact, I'll delete that as well. So we've basically got a blank class here. On your keyboard, though, if you press Alt, which is the key to the left of the spacebar, and the Insert button, Insert on my keyboard is to the right of the backspace key, near the home and end if you've got a full-size keyboard. So if we press that, we get this code generator. So you can see that we can generate all of the getters and setters. You might not necessarily want them all doing, so you can pick and choose which ones you want. We'll go for all of them. And I'm going to put some more space in, press Alt and Insert again. I'm going to create a constructor. Again, we get to choose which variables we want. Here we go. And then lastly, I should probably go to the end of the class for this one. I'm going to do the toString method. There we go. So you can see all of that code has been automatically generated, and all we really need to do is just tidy it up a little bit. But it saves typing a lot of repeated code, although I must admit I quite like typing some of them out sometimes. Sometimes I do feel a bit lazy. But anyway, I'm going to undo all of that and put that code back to how it was. Except for I'll change that there. And then we'll head back here and then see what our challenge is. So this is a 3-parter. Very nice. So you'll notice here that we've got the exercise health station. If we flick to NetBeans, you can see that we've got the biggest pet shop. Health station is number 9. So if yours is a bit different, we're going to continue with the health station here, and we actually do the biggest pet shop a bit later on in this session anyway. So I'm going to close that. Okay, let's have a look and see what we've got in our classes. So we've got a health station class, we have a main class, and we have a person class. Drag that one over here. Okay, and right, let's have a read of the challenge and see what we need to do. So in the exercise base, there is a class person, which you're already quite familiar with. There is also an outline for the class health station. The health station objects process people in different ways depending on their weight. In this exercise, we will construct a health station. The code of the person class will not be modified in this exercise. Okay, that's good to know. So in the outline of the health station, there is an outline for the method weigh. The method receives a person as a parameter and is meant to return to its caller the weight of the person. The weight information can be found by calling a suitable method of the person. So your task is to complete the code of the method. Here is the main program where a health station weighed 2 people. Right, so I'm going to move this to the right. Let's move that to the left. I'm going to minimize my projects. And, oh, I'm a navigator. Go. I'm going to copy this. Where is it? This code in. No, that's really lazy. I'm sure you don't want me to hear me constantly typing on my keyboard. So let's pop that in there. And let's head across to our... Oh, actually, it said don't edit the person class, didn't it? Let's see. Code of the person class should not be modified. That's fine. Let's have a quick look in the person class anyway and just see what we've got, because we're going to need to retrieve or use the methods potentially of that class. So we've got name, age, height, and weight. We've got set height, is of legal age, get height, get weight, set weight, BMI, get name, and toString. Something quite cool that I found out the other day is that you can actually drag the classes out of the editor. So if you've got multiple screens, you can drag one of them across onto a different screen. Quite cool. Right, so this method here needs to return the weight of the person. So my initial thought is that we need to just update this method, as they've said, and we should be able to get that weight printed out quite nicely. I reckon we should be able to just do return person dot get weight like that. Let's give that a run locally and see what happens. Okay, we've got some passed. Implement a public method void feed. Oh, okay, so we passed the first bit. Let's go back and have a look at the second bit. So that one's done. We should actually have 1 point now, I guess. Oh, we don't. That's fine. Let's see. So we've got that printout. There we go. So we've got the printout as we expected. So what's happened, well, what's happening here is that we're making a really good use of our objects. So let's just tidy this up. Oh, wrong one. Let's just tidy this one up a bit. There we go. So this system out is really doing a good deal of the work of pulling everything together. So you can see here that we're using the Ethan object, which is on line 9. Then we're using the getName method from the person class. So if I was to type here, Ethan, because he's an object of our person class, you can see that we've got these bold options. These bold ones are all of the options from the person class. So we've got get height, get name, get weight. The regular font ones are just methods that come as default as part of the object class. And then we've got the same with Peter as well. So we've got the object Peter on line 10. And then if I type in Peter, dot, and then you can see that we've got access to those methods. And the same thing's happening here with Children's Hospital. So if I type out Children's Hospital dot, we should only get one custom method that we've created. So you can see here that we've got the method way, which is the only method in here that we should have access to. So we just move over a little bit. So what's happening here is that we are calling the Children's Hospital object, then the .way method. And if you remember, the .way method here is taken a person as the parameter, or as the data that's going to be worked on. So we're passing Ethan, and then we're returning Ethan's weight, and then we're passing Peter and returning Peter's weight. Right, let's have a look back here. So it is possible to modify the state of the object that is received as parameter. Write a method called public void feed person for the health station. It should increase the weight of the parameter person by 1. So following is an example where people are weighed first, and then Ethan is fed 3 times in the Children's Hospital, and then after this the people are weighed again. Okay. What I'm going to do is pinch this code. So this is the stuff that we've already got. I'll take this and paste it in here. We go. So you can see 2 things. Firstly, my code isn't lined up nicely. So I'm going to use Control A to select all of my code, and then press Alt, Shift, and F on my keyboard, and that auto indents everything. Here we can see that we've got an error because it can't find the method feed. We could cheat and press Alt and Enter, and it would create the method for us. We can also click this light bulb, and it will give us the same option to create the method for us. But where's the fun in that? So what we're going to do, or I'm going to do, is type PU, press the tab button, and this is going to be a void. We're going to call it feed, and then remember the parameters that we're passing, not parameter, the parameter that we're passing is the person. And then what we need to do is return person dot. Actually, let's see what we've got, because there should hopefully be a method. In fact, there will be a method, I'm sure. We've got grow order, set height, get weight, get toString. Okay. So we wouldn't actually have a return because it's a void for starters. And what we would do is say person dot and then set weight, and it's expecting. If we put a 1 in there, every time we call that method, it will set weight to 1, which actually isn't what we want. So what we can do is, the first thing we're going to do is get the weight. So we can do person dot get weight, and we're going to say that person dot get weight is going to be equal to current. So that's going to be current weight. Oh my days. And then we're going to do current weight plus plus. We're going to say person dot set weight, and we're going to set the weight with the current weight. There we go. Let's give that a run and see what happens. Give it run locally. So the first run we had 3 greens and then the rest reds. We've got some more greens there. That's good. Let's just have a quick look and see what the last one is. Implementing method public int weight. So that's good. So we know that we've done that because this must be part of the next exercise. The reason I did it this way as well is because if we just did person set weight plus 1, their weight would be constantly updated and equal to the value 1. So actually, just having to think about it, I think I've got a different way that we can try. And what I'll do is I'll implement that and then we'll test it. So we'll do person dot set weight, and we're going to set the weight with the person dot get weight. Can we do plus plus? Right, +1. There we go. Let's give that a run locally and just make sure that we get 75% again. And that's a much cleaner way of writing the code, I think. There we go. So we still got 75. So that implementation is better. Right, let's get this back over here. And then let's have a look at this final section here. So part 3 is called counting weights. Create a new method called public int weighings for the health station. It should tell how many weighings the health station has performed. You will need a new object variable for counting the number of weighings. Okay, great. Let's take this code then. And put it in there. Let's just give it a tidy up. Okay, right, let's just create the object variable. So private, we'll call it weigh-ins, just the same as they have. Just check their spelling, ings. So if I actually just show you something quickly, if we do create that method, it implies that it implies the data type. So because it's linked in the string literal, presumes that the weighings will actually be a string, when it makes more sense for us to use an int. So I'm going to change that. So it's going to be public int weighings. So we've got our variable, we've got our method here. What we're going to do is return weighings. I can't type today. I don't know what's wrong with me. There we go, return weighings. How we're going to update this is by using the weigh method here. So let's just go to a new line and then say weighings plus plus. Give that a run locally. See what happens. Oh, there we go. Excellent. Let's get that one sent off over there. And let's give our Challenger refresh, make sure we got our points. Ooh. Oh, because he hasn't submitted properly yet. Right, well, let's open Bash while that's doing that. There we go. There we go. Excellent. Cool. So we'll update Git Bash as well. So we'll open our projects again. So just going to right click on Health Station and get the project link. So it's in sources and then project folder. Okay, so we'll type in cd for our change directory. Shift and insert to paste in the location here. And we need to get rid of the backslash. Actually, I'll show you what happens if we don't get rid of it. If we don't get rid of the backslash, you get this coming up. So if I go back, get rid of the backslash. So we've got program and I. There we go. And then we can do our git add. And then our git commit -m completed part 5 exercise 9, and then git push u origin master. There we go. Excellent. So we can close this one down now. We'll stop the video here. This is quite a long section. So until next time, good luck and happy coding.